Hello coders, I welcome you all. In this video, we are going to discuss NLP, Natural Language Processing, with fundamental concepts such as tokenizing, stemming, lemmatization, POS tagging, means part of speech tagging, etc. In the future, we will use these concepts to create cool NLP projects. We will explore these ideas through practical examples using the Python library Spacy. So let's get started. As you can see here, NLP is the bridge between human and machines, where computers speak our language. In this video, we will discuss what NLP is, why it is important, where it is used, how it works, and fundamental NLP concepts through practical demonstrations. Watch this video until the end. I'm sure you will learn something. Now, first, let's start with what NLP is. NLP is about teaching computers to understand and use human language. It's about making machines talk like us. Think of ChatGPT, where a computer can chat with you like a human, or BERT, which understands the context of your words in a sentence. Now, moving on. Why is NLP important? Well, NLP enables computers to communicate with us, making things like voice assistants and the language translation possible. It significantly contributes to making technology more user-friendly. Now, where is NLP used? Please remember, NLP is everywhere. It's used by Siri and Alexa to understand us. In social media, it analyzes feelings through sentiment analysis. NLP also plays a role in translating languages on your phone. Examples like ChatGPT and BERT showcase the power of NLP in creating intelligent conversations and understanding context. Now let's move on to the question, how does NLP work? NLP involves processes like tokenizing, stemming, lemmatization, POS tagging, etc. Essentially, it is like teaching a computer to read between lines. Now let's move on to our practical part, where we will discuss some essential concepts of NLP. Understanding and applying these concepts will be crucial in building NLP-related projects. We will start our discussion with tokenization. Tokenization involves breaking down a piece of text into smaller chunks. After that, we will move on to stop word removal. These words are frequently used in a language but typically do not contribute much to the meaning of a sentence. Next, we will explore stemming and lemmatization, which is the process of reducing a word to its base or root form. Following that, we will talk about POS tagging, which is part of speech tagging, which involves assigning grammatical categories such as noun, verb, adjective, etc. to each word in a given text. Afterwards, we will discuss named entity recognition, which involves identifying and classifying named entities such as persons, organizations, and more in a given text. Finally, we will cover sentence segmentation, the process of identifying the boundaries between sentences in a given text. Throughout our discussion, we will touch on various other related concepts as well. To practically implement these concepts, we will use Python's Spacy library. Let's jump to Spacy official website. As you can see, currently I am using spacy.io, which is official website of Spacy. As you can see here, what is Spacy? Spacy is a free open source library for advanced natural language processing in Python. As you can see here, Spacy is designed specifically for production use and helps you build applications that process and understand large volumes of text. So we are going to use this library, Spacy, to practically implement all the concepts that we just discussed. Now let's start our discussion with tokenization. Tokenization is a process in natural language processing where a sequence of text is divided into individual units called tokens. This step is crucial in preparing textual data for analysis and modeling in NLP tasks. Tokens are like the building blocks of a pieces of text. When we are trying to understand what a sequence or paragraph means, we look at these tokens and how they relate to each other. They are the basic units that help us make sense of the text. As you can see in this example, to our right side, text input. This is our input text. As you can see here, after tokenization, we now have 6 tokens. Tokenization is essential in NLP and this period science. So after tokenization, we now have 6 tokens. 1, 2, 3, 4, 5 and 6. Now let me show you this practically. So let's jump to Google Colab. As you can see, this time we are using Google Colab because almost all the required libraries for data science are pre-installed, including Spacy. So let's use the same input we just discussed in the presentation. So let's write S1 is equal to this text. Tokenization is essential in NLP and this period sign. Let's execute this cell. I'm pressing Shift plus Enter. So you can see we have initialized this text. Now let's import Spacy. Let's execute this cell. Now after that, we need to load a pre-trained model from Spacy. So for this, we have to use Spacy.load method of Spacy. And here we have to pass name of the pre-trained model available inside Spacy. And for English underscore core model, web underscore SM. SM for small sized pre-trained model. So here this en underscore core underscore web underscore SM is the name of the pre-trained model. Let me assign it to one variable, NLP. You can use any other name as well. Let me execute this cell. As you can see, now our pre-trained model is successfully loaded. You can see that a small sized pre-trained model of Spacy is installed by default that you can see over here. We not required to install this small sized model. If we want to use other models such as medium or large models, we need to install them. Let me show you this. Let's jump to Spacy website. As you can see here, just click on this models tab. You can notice that the Spacy website is well formatted that you can see over here. And the website itself serves as a valuable resource. It provides a self-introductory overview that you can see over here. Spacy is supporting these many languages that you can see over here. Let's click on this language, English. You can see 4 pre-trained models for English that you can see over here. The first is small sized model, approximately 12 MB, trained on small dataset. The second is a medium sized model with a size of around 40 MB. And the third is a large model with size of 560 MB. And lastly, there is a transformer with a size of 436 MB that you can see over here. So in this tutorial, we will use the small size model, but you can choose any other model based on your requirements. As I said, small sized pre-trained model of Spacy is installed by default. If you want to use other models such as medium sized or large sized models, you will need to install them. Let me show you this, how to install medium sized model. Let me click on this n underscore core underscore web underscore MD. Here MD is sized, medium sized. And here you can see to our right side, we have to use this command. Let me copy this and let me paste it over here. So this command will download medium sized model. We have to add exclamation sign front of this command. Let me execute this cell. As you can see here, downloading process has been started. We have to wait. As you can see here, download and installation successful. Here it is showing you can now load the package via Spacy.load that you can see over here. So now we have already imported Spacy. So let's write Spacy.load and let's copy this medium sized model and let me assign it to one variable. NLP1 is equal to this statement. Let me execute this cell. As you can see here, we have successfully loaded this medium sized model. So this way you can download different models as per your requirement that you can see over here. Now let's continue our discussion on tokenization. Here is our statement and we want to tokenize it. Tokenization is essential in NLP and here we have imported Spacy library and this line of code loads a pre-trained English model, small sized model from Spacy, right? It assigns this model to the variable NLP. This model is ready to perform various natural language processing tasks. So as you know, this line defines a string S1 with the text tokenization is essential in NLP. This is the input text we want to analyze using Spacy. So for that, we have to give this text to our pre-trained model using this variable NLP that we have created over here. And let's pass our text S1 and let's assign it to one variable. Doc is equal to this statement. Let me execute this. You are wondering, what does the model do? As soon as the model is called on a text, it puts the text through a processing pipeline. A processing pipeline is a series of steps or called as functions that the model performs to understand the text and prepare it for further processing. And here we have used doc is the convention for storing the objects returned after processing. Still not getting? Let me explain you one more time. Let's jump to Spacy website. So as you can see here, this is our input text. As I said, as soon as the model is called on a text, it puts the text through a processing pipeline. So this is our processing pipeline. And you can see here it is called as NLP, this one. A processing pipeline is the series of steps or called as functions that the model performs to understand the text and prepare it for further processing. So as you can see here, when you call NLP on a text like this, Spacy first tokenizes the text to produce a doc object, this one. Also we have used same convention, doc over here. So when you call NLP on a text, Spacy first tokenizes the text to produce a doc object. The doc is then processed in several different steps. This is also referred to as the processing pipeline. So this is the processing pipeline. This pipeline performs following functions on the input text: tokenizer, tagger, parser, NER, etc. When we use a pre-trained model on our text, it goes through some basic steps. These steps that you can see over here together are called the pipeline. So this is our pipeline. The result is a doc object, this one. With this doc object, we can check the output of each step in the pipeline. I'm repeating, using this doc object, we can check the output of each step in the pipeline. Don't you worry. We will discuss each of these steps one by one. We can also display these basic steps which are performed on our input text in our code as well. Let me show you this. So for that, we have to use NLP.pipeline. Let me execute this cell. As you can see here, we can see the basic steps of the pipeline that are performed on our text that you can see over here. The basic NLP pipeline includes talk to vec, tagger, parser, lematizer, and NER, which is name entity recognizer that you can see here. We can obtain only the basic names using NLP.pipe_names. Let me execute this cell as you can see over here. So these are the basic steps of the pipeline that are performed on our text. This one. If you are new to this, don't you worry. We will discuss these components practically one by one. But let's start with the tokenization first. As I said, tokenization is performed before the rest of the steps in the pipeline. That also you can see here. When you call NLP on a text, Spacy first tokenizes the text to produce a doc object, right? So let's first discuss tokenization. It splits the text into tokens, right? So let's visit once again Spacy.io, official page of Spacy. As you can see here, tokenization. During processing, Spacy first tokenizes the text, segments into words, punctuation, and so on. This is done by applying rules specific to each language. Currently, we are using English language. For example, punctuation at the end of a sentence should be split off, whereas UK should remain one token, right? Each doc consists of individual tokens and we can iterate over them. That I will show you shortly. As you can see here, this is the input text and you can see output after tokenization that you can see here. So now how Spacy performs tokenization? So first, the row text is split on white space characters, similar to text.split function that we are using in Python. Then the tokenizer processes the text from left to right. On each substring, it performs 2 checks. So these are the rules that will be applied to generate tokens from the given text. First, does the substring match a tokenizer exception rule? For example, don't does not contain white space but should be split into 2 tokens, do and apostrophe t, while UK should always remains 1 token. So this is exception rule of Spacy. That also you can see here to our right side, tokenization exception, special case rule to split a string into several tokens or prevent a token from being split when punctuation rules are applied like this. Don't is splitted into two tokens. Do apostrophe T. While UK should always remain one token. This is exception rule which is applied on the text that you entered. Second, can a prefix, suffix or infix be split off? For example, punctuation like commas, periods, hyphens or quotes that you can see over here. Prefix, characters at beginning. These are the different characters possible at the beginning. This dollar sign, parenthesis, quotes, etc. Suffix, characters at the end like km for kilometer, closing parenthesis, double quotes, exclamation sign, etc. Infix, characters in between like hyphen, double hyphen, forward slash, etc. As you can see, one nice example is given. You can observe the text let's go to NY with an exclamation sign and the strings are enclosed in double quotes that you can see over here. In this case, the tokenizer processes the text from left to right. On each substring, it performs two checks. The first rule applied here is the prefix rule, which splits double quotes that you can see over here. Prefix rule, characters at the beginning. You can see over here, splitted over here. After exception rule is applied, you can see here, tokenizer exception. Special case rule to split a string into several tokens or prevent a token from being split when punctuation rules are applied. So here exception rule is applied on this let's and which is splitted into two tokens, let and apostrophe s that you can see over here. After that, this suffix rule is applied which split these quotes that you can see over here, characters at the end. Once again, suffix rule is applied to separate this exclamation sign that you can see over here. And finally, again, exception rule is applied to prevent a token from being split when punctuation rules to prevent this token from being split n.y. And finally, done. So these are our final tokens after applying these many rules that you can see over here. So this way Spacy performs tokenization that you can see over here, which is very essential step in text pre-processing that you can see over here. Now let's continue our discussion on tokenization. So now we have successfully created this doc object. So now to display tokens, we have to iterate to this object. So for token in doc, let's print token. Let me execute this cell. As you can see over here, our tokens. To find the number of tokens, we have to use Python's length function, len, on our doc object. As you can see here, from these statements, 6 tokens are created by Spacy small sized model that you can see over here. 1, 2, 3, 4, 5 and 6 that you can see over here. Now let's take another example. S2 equal to I found a great resource at https www.example.com for learning NLP. Let me execute this cell and let's create another doc object. Let's pass our text to NLP. Let me execute this cell. Now let's write for token in doc1 and let's print token. Let me execute this cell. As you can see over here, Spacy model has successfully tokenized the input sentence, breaking it down into meaningful units. And also you can observe that the Spacy tokenizer is designed to recognize and handle various types of tokens, including URL. So in this case, it identifies the entire URL as a single token and acknowledging it as a distinct element in the text that you can see over here. So this behavior is beneficial when analyzing or processing text data, as it allows for a more accurate representation of a language structure and content that you can see over here. Also, let's write NLP or email me at example@gmail.com. Let me execute this cell. Also, let me execute this cell and this cell as well. As you can see over here. In this case, it identifies the entire URL and email address as well as a single token that you can see over here. So let's take another example. So S3 equal to, let me write the laptop cost $1,000, but it was sell for $8,000. Now let's use our pre-trained model on this particular text and let me assign it to one variable doc3 is equal to this statement. Let me execute this cell. Now let me write for token in doc3 and let's print token. As you can see over here, words such as the laptop cost this $sign 1,000, comma, but it was sell for $8,000 that you can see over here are treated as an individual tokens. And here you can observe the Spacy's tokenization treats the $sign and the subsequent numerical value 1000 and here 8000 as separate tokens that you can see over here. So this way Spacy performs tokenization that you can see over here. On our input text, let's take one more example of tokenization. S4 equal to, let me write, let's go to park and enjoy the beautiful weather. Let me execute this cell and let's pass S4 to our pre-trained model. And let's assign it to one variable doc4. Let me execute this cell. Now let's display token in doc4. Let's print token. Let me execute this cell. As you can see here, different tokens are created from this text. Here you can see let and apostrophe s are splitted and considered as 2 tokens that you can see over here. As I said, we can find the number of tokens using this len function. As you can see here, 11 tokens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. As you can see here, now we have created tokens from the sentences using Spacy. Similar to Python, we can perform indexing and slicing on the tokens created by Spacy. As you know, in Python, indexing and slicing are techniques used to access elements or sub-elements of a sequence, such as string, lists, or tuples, right? So let's go through examples of indexing and slicing using strings in Python. As you know, indexing refers to access individual elements of a sequence using their position, starting from 0 for the first element. So let me write text equal to hello world, and we can print first character at 0, index, this one. Second character 0 and 1 at index 1. Also we can use negative index in Python. Here -1, -2 likewise. So this is the last character D that you can see over here. So as you can see in this example, the variable text is a string and we access individual characters using square brackets and the index that you can see over here. Slicing involves extracting a portion of a sequence by specifying the range of indices. Let me show this. So again, let me write text as Python is powerful. Let me execute this cell. So here the syntax of slicing is start, stop and step. So where start is the index to begin the slice. Stop is the index to stop, which is exclusive. Start is inclusive, but stop is exclusive. I will show you shortly. And the step is the size between elements. So here, let me write text 7 to 9. Here, index 7 is inclusive, but index 9 is exclusive. As you can see here, is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here, 7 is inclusive and 9 is exclusive. Also, let's give only step size 3 that you can see over here. E, then 0, 1 and 2, then H, then space, then W, F, then out. So here we can give start, stop and step size in slicing. So now let's work with tokens created by Spacy. So let's use one new sentence. Indexing and slicing are important concepts in Python. Let me execute this cell. Now let's create doc object by applying this text to our pre-trained model NLP. Now let's display first token. So doc, and which is available at index 0. And let's perform slicing 3:8. And let's assign it to one variable token underscore range is equal to this statement. So here indexing, get the first token. And here you can see slicing, get tokens from index 3 to 7. As you know, first one is inclusive and last one is exclusive. So let me execute this cell. Now let's display first token and first underscore token. Let me execute this cell. As you can see here, first token. Now let's display tokens after slicing. For token in token underscore range and print token. Let me execute this cell. As you can see over here, tokens from 3 to 7 that you can see over here. 0, 1, 2, 3, 4, 5, 6 and 7 that you can see over here. First one is inclusive and last one is exclusive. That's why period is not displayed over here that you can see over here. So this way we can perform tokenization and indexing and slicing using Spacy that you can see over here. Other essential concepts of NLP we will discuss in the next video. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.